and we're holding here a classic piece. You see the ironstone with the silica opal, but also on the other side of the opal is quite interesting because you have the formation, the sludge.
Or the scum,
if
you like,
where the opal stops. So if you just can for a minute explain to us your idea of formation of opal, Rod.
The traditional belief is that opal was formed by water percolating down through the silica-rich soils, and then getting to a point where there were cavities where it would settle, and then over a long period of time, as it solidified, it turned into opal, either gem opal or hotch opal. An alternative is that it is from hot fluids coming up, not cold fluids coming down. Now, over the years of cutting all the opal, if it came down and settled over a long period of time, all the layers of colour in the opal would be absolutely parallel and horizontal. Well, I've got numerous examples where the colour swirls and bends, and you've got fractures in it, you've got interruptions in these bands of colour. So where this hot fluid has been forced through the surrounding materials. Now, sometimes in this ironstone, you'll find this little grain of ironstone, and the opal will have flowed around that grain of ironstone. Now, we've also found that with two-phase inclusions in the opal, where you've got a fluid-filled cavity with a gas bubble contained in that. And when the opal moves, the little bubble moves around, like in a perk of a diamond, which is fairly common to have these little two-phase inclusions.
More so in these material from the Hindu Kush Mountains, yes. The three-phase included quartz.
Yes, the two-phase, three-phase inclusions. Well, I have a beautiful piece of opal with one of these in it. So the indications are that it's through hydrothermal formation, not sedimentary. And that's why the hot fluid's coming up, filling these cavities. Unlike any hot fluid, if you have a melt, in a furnace you're melting some lead, you throw in a bit of borax and the scum rises to the surface. The scum rising to the surface here. Now, there's the fissure in the ironstone. This boulder didn't ever fill because there was not enough silica solution to completely fill the boulder. Horizontal, absolutely horizontal, yes, up. Still fluid, but it's flowed into these cracks and cavities.
And show us the other side. So what's the idea with that? The iron, the silica itself.
There's the silica. See, it's flowed up. And you can see the crack there has not been completely filled because the rest of this boulder was up here until I sawed it off. So there was not enough opal solution to completely fill this boulder.
Okay, so going on the theory that
hot fluids, the hot theory of hot fluids, we can see here there was a band of what would have been just hotch opal because there's very little play of colour in it, and then it's been interrupted and intruded on by another flow of silica solution. While this was maybe just in a gel form and still sort of thickly fluid, there's been another intrusion of hot fluids and it's flowed through the original.
Do you have other examples?
Oh, lots and lots of them. I've been taking them all as I've been cutting over the years. That had been a fluid-filled cavity.
And in hydro.
And hydro. And you can see, you've got opal, it's been intruded, and the intrusion carried fluid with a gas bubble in it.
Wow.
At the head of that intrusion, flowing.
Where's that example of the piece of ironstone where the opal flowed around it?
Now look at this teardrop. Now there's that colour. Oops. There's the colour. So what's made it do that?
The cavity?
Hot fluids, just
hot fluid
flowing up.
Wow.
But that hasn't sat there. Now there is a two-phase inclusion in an opal.
And that's gas bubble or water?
That's a fluid. What the fluid is we don't know, because the only way you'd ever find out chemically what the fluid is to break the bubble, drill a tiny hole in, and then there's the gas bubble contained within the irregular fluid.
And there's one just north of the black spot as well.
And another one just here, very tiny one there, and then this had been a third one that I actually broke through before I realised what the piece was.
Interesting.
Now they're just numerous. Now once again, here's our boulder that's only been partly filled. There's your scum line.
Extremely interesting, Rod.